Alright guys, so this is example problem 2.A.4. So this problem basically states that we have two racks. Rack A moves to the right with this acceleration and velocity and acceleration, while rack B moves to the left at a constant velocity. Also, between the two racks and the gear, there is no slip. That'll be important to know later on. So we are given the velocity of A, the acceleration of A. We're also given the velocity of B. We're also given the two radius, the inner radius for the gear and the outer radius. The point we're concerned about is point P here. We're asked to find the velocity and the acceleration. To do this, we'll start with a simple equation here. The velocity of A in the I hat component is equal to the negative velocity of B in the I hat component plus omega K hat cross R of A of B. The reason why it's in the I hat component here is because both racks A and B are constrained only to move in the I hat direction, not in the J hat direction. So, simply using the equation that we have, we just break it down, get W by itself on either side here, and then so then omega ends up being negative, parenthesis, velocity A plus the velocity of B divided by the big radius, divided by the small radius in the K hat direction. Next, to find the acceleration, we'll use the equation, acceleration of A is equal to acceleration of B plus alpha cross A of B minus omega squared R A of B. Now, like I said before, this is a no-slip equation. What's important to know about that is here at rack B, where the gear touches the rack, there is no acceleration in the I hat component, meaning there's only acceleration in the J hat component. So next we want to split up the equation into I hat and J hat components only. So we'll get the acceleration of A in the I hat plus the acceleration of A in the J hat component is equal to the acceleration of B in the J hat component plus alpha multiplied into large R plus the small r in the I hat component minus omega squared of the large radius plus the small radius in the J hat component. In this instance, we're only worried about the I hat component. So if we compare terms, we simply are left with the acceleration of A in the I hat component is equal to negative alpha times large radius plus small radius. Solving for alpha, we are left with negative acceleration in the A divided by large radius plus the small radius in the K hat direction. Now that we have simply found the components we needed for A and B, we can now use these next equations. So velocity of P is equal to velocity of A plus omega crossed into R of P of A. So we have already found earlier the equations that we needed. Simply now we need to find the radius of P over A, which is simply the large radius minus the small radius. So from there we can go ahead and plug those components in. And when you end up solving, you end up getting the velocity of P is equal to the velocity of A plus omega in the R with times the small radius in the I hat component plus omega times the large radius in the J hat component. Now moving on to the acceleration of P. The acceleration of P is equal to the acceleration of B plus alpha cross R of P of B minus omega squared of R of P of B. In this case, R of P of B this time is the large radius plus the small radius. So now simply plug in. We know the acceleration from the previous equation of A of B is simply A of B in the J hat component. So we'll plug that in there for what we know. Simply following in, we'll continue plugging in everything else that we found out previously. Once that is done, what you will end up with is A of P is equal to negative alpha large radius minus omega squared large radius again in the I hat component plus the acceleration of B in the J hat component plus alpha R minus omega squared R. Both those R's are the large radius in the J hat component. Now, this isn't going to give us exactly what we need. We still need one more thing here. So what we're going to do is we're actually going to find the acceleration here at O. The acceleration here at O is A of O in the I hat direction is equal to A of B J hat plus alpha K hat crossed into R J hat minus omega squared r in the j hat component. So you get that from the previous equation of a acceleration of O is equal to a of b plus alpha cross r O of b minus omega squared r O of b. When you end up solving that, what we want to do is we want to compare terms only in the j hat component. Doing that allows us to solve for a of b, which ends up equaling omega squared r. Now that we know what a of b is, we'll simply plug it back into a of b with all the other components that we found so far. A of p ends up equaling negative alpha r, large r, minus omega squared, large r, in the I hat direction. Since a of b end up being omega squared r, we have a negative omega squared r. Those two terms end up canceling out, leaving us only with alpha r in the j hat direction. So the overall equation to find the acceleration of p is negative alpha, large radius, minus omega squared, large radius I hat, plus alpha, large radius in the j hat component. Now simply plug in all the variables we were given initially, plus all the variables that we have found before, and what you end up getting is omega ends up equaling negative 5.38 radians per second. The alpha ends up equaling negative 7.962 radians per second squared. Plug those in from the things we found before. Finding velocity of p is equal to 1.1231 meters per second, and the acceleration of p is equal to negative 6.030 meters per second squared.